Hi guys, welcome to our last new video lesson of this chapter. We're on video 2 of the last day of new stuff. Don't forget, you should be taking notes on all of this so that you have something to study for our test. In this video, we're going to do some more complicated absolute value equations. So in the first video, I feel like everything was pretty straightforward. Maybe we weren't ready to get 2 answers, but hopefully we were able to do those. These are going to be a little bit more complicated. Here is our first example. In this problem, again, I have an absolute value equation. The thing that's a little bit new on this question is I've got a bunch of other math happening on the same side as the absolute value bars are. That didn't really happen on the last one. On the last one, it was the absolute value bars was equal to a number. We need to make that happen on this one. To do that, what we're going to do, we can't move anything like out of the absolute value bars because they're kind of trapped inside of there. But I can take anything that's not in the absolute value bars and I can move those to the other side. Sometimes what I'll do on these problems is I'll pretend like the entire absolute value bars is my variable. So I'm going to cover up the absolute value bars with a big letter X so that I don't accidentally try to move stuff out of it and so that I can really clearly see what I'm trying to move to the other side. And so I'm going to pretend for just a little bit that this problem actually says 2x plus 6 equals 8. And I'm going to solve for that blue x. So I'm going to minus 6 on both sides, and I'm going to divide both sides by 2. Now that I have the blue x by itself, now I can approach this as I did in the problems from the previous video, where I have an absolute value equals a number. I'm going to split it into 2 separate problems. The first problem looks exactly the same as the original question without the bars. And the second problem, I've changed the sign of the outside number, not the inside numbers, the outside number. Now, you're not allowed to do this whole splitting thing until you've gotten the absolute value bars by itself. So that is a very important pre-step. Make sure that the bars are by themselves before you split it. Now I will solve each of these individually, getting 2 completely different answers. My first answer is 5/3. My second answer is 1. Both of those are considered answers. When you're doing your Delta Math tonight, you'll need to type in 5/3, 1 so that you can enter in 2 answers. Okay, hopefully that wasn't too intense. We are going to continue with one more example in this video. Here is our second example. Now again, this one is going to be a little more intense than the last one. Again, we have our absolute value bar. In this problem, the absolute value bar actually is already all by itself. So that's fantastic. Like, that's what we need to happen. The thing that makes this problem more intense is that we have a math problem on the other side of the equal sign. It's not just a number. It has variables. It has an adding sign. And so that's going to make this one quite a bit more intense, actually, than the previous problems. All right, but we're actually going to start this problem the same way that we've been doing the other problems. And so I'm going to take it and I'm going to split it into 2 separate problems. And for the first problem, I'm going to write it exactly how it looks right now. And so I have the 5x minus 2 equals 7x plus 14. And the only thing that I've changed is I got rid of the absolute value bars. Now for the second problem, we need to change the sign of the number on the other side of the equal sign. But in this problem, it's not just a number. So we need to make sure that we're changing the sign of the entire right-hand side of the equation. So I went ahead and I put it in parentheses with a negative on the outside so that I'm making the whole thing negative, and then you are going to distribute that negative. You also could just change the sign of everything. So it was a positive 7, make it a negative 7, and it was a positive 14, make it a negative 14. Okay, so that was a little bit trickier. We're going to solve these as we have been. Hopefully that part is not too difficult. All right, so on the first one, I'm going to add the 2 to the other side. 14 plus 2 is 16. On the second one, I'm also going to add 2 to the other side, but this time it's 2 plus a negative 14. And so since it's a negative 14, we get a different number, negative 12. Next, I'm going to move my x's together. So I have subtracted this 7x. 5 minus 7 is negative 2. On this one, it's a negative 7. So I'm not going to subtract it. I'm going to add it because it was a different sign. So 5 plus 7 is 12. And then we finish up these problems with division. On the first one, I'm dividing by a negative 2. And on the second one, I'm dividing by a 12. And I get my two answers are negative 8 and negative 1. Now, in our first video, we talked about checking our answers. We talked about plugging them back in, making sure that they work, making sure that they give us a true statement. In a problem like this, it's very, very, very important that you are checking your answers and making sure that it gives you a true statement. Very specifically, if you have an absolute value problem that has a variable that's not in the absolute value bars, you have to check your answers. Mandatory, required, 100%, can't get away with not doing it. And I'll show you why in a minute. So let's check our answers. These were the two answers that I got. And this was the original problem. When you're checking your answers, it's very important that you're plugging them back into the original problem, not one of the ones that you created. I'm going to start with the negative 8. So I'm going to plug negative 8 in everywhere I see a letter X. I'm going to simplify each side of the problem until it's down to a single number. And I get this. The absolute value of negative 42 equals negative 42. This is not a true statement. The absolute value of negative 42 is positive 42, not negative 42. Absolute values can never equal a negative number. Absolute values always must equal a positive number. And so since I get a false statement, since it says negative 42, the absolute value is equal to negative 42, and that's not true, that means negative 8 is actually not an answer to this problem. When I plugged it in, it doesn't work. And sometimes that happens. Specifically, that's definitely going to happen on these problems where there's a letter X not inside the absolute value bars. So you have to check your answers. Sometimes neither of them works. If you check your answers and none of them work, then you're going to write no solution. Here's a little vocabulary word for you. Negative 8 is called an extraneous solution. If you take an answer and plug it in and it doesn't work, and so it's not really an answer, it's extraneous. Let's check and see if negative 1 is also extraneous. So I'm plugging it into the original problem, and I'm simplifying each side individually. In this problem, I get the absolute value of negative 7 equals positive 7. That is a true statement. The absolute value of negative 7 is positive 7. Even though x was equal to a negative number, that doesn't mean that that number is wrong. It's only wrong if you plug it in and this outside number is negative. That's what makes an answer wrong. So negative 1 does work when I plug it in. So just to clarify, you are allowed to get negative answers to this problem. You just can't have an absolute value equal to a negative, but your answer itself can be negative. And so the only answer to this question is negative 1. So even though I got two answers, one of them was extraneous. On your Delta Math, you would only type in the one answer, not both of them. On your worksheet homework, you will only write down the one answer, not both of them, for a problem like this. This concludes our Chapter 1 lessons.